Hi there everyone! So today we're going to be talking about function notation, operations on functions, and evaluating functions. Now this is going to be a multi-day lesson, so just keep that in mind. We will not be finished with this lesson topic just after today's lesson. So let's just get started right into it. We're going to start by evaluating the first function. So I have g of x is equal to negative x squared plus 4x plus 1. And let's do part A together. So we have g of 2. So this is my input, really, where x is equal to 2. So I have g of 2 is going to equal, we have negative 2 quantity squared plus 4 times 2 plus 1. I have negative 4 plus 8 plus 1. You guys do not need to use a calculator. We have 4 plus 1, which ends up being 5. So that's just evaluating our first function. You're going to do B on your own, and let's just take a look at C. So now my new input for x is now going to be x, so I'm going to say x in quotations is now x plus 2. So wherever you see an x, we're going to replace it with an x plus 2. So now I have g of x plus 2 is going to equal negative x plus 2 quantity squared plus 4 times x plus 2 plus 1. Okay, I'm just going to skip over the double distribution. You guys should know how to double distribute. We end up with x squared plus 4x plus 4 plus distribute. We have 4x plus 8 plus 1. Okay, just combining like terms here, so let's distribute here as well. I'll have negative x squared minus 4x minus 4. Making sure I haven't made any mistakes, plus 4x plus, this is really 9, and we'll be left with negative x squared. These cancel, and I'm left with plus 5. All right? Okay, so moving right along, this was all on page 10. We're going to skip over to page 12. So we're going to take a look at question 2 together. All right, so question 2 together. So this tends to be confusing for students, but just bear with me. Before we said our x became whatever was newly inside the parentheses. So if I was looking at this function as f of x, our new x is now x plus h. So wherever you see an x, you're going to replace it with an x plus h. So wherever you see an x, we're going to replace it with an x plus h. The common mistake that a lot of students make is they'll write this, f of x plus h equals, and this is wrong, what I'm writing, is 3x squared minus 2x, and they'll just put a plus h at the end. Okay, that's not what this is saying. So again, we're going to replace, so now I have everything where I see an x, I'm going to rewrite it with 3 times x plus h squared minus 2 times x plus h. After some double distribution, this is x squared plus 2xh plus h squared minus 2x minus 2h. We're going to distribute here. We'll have 3x squared plus 6xh plus 3h squared minus 2x minus 2h. And then I'm just going to combine my like terms. Oh no, I can't. That's actually my final answer. There are no like terms to combine. This is it. A long answer. Okay, so moving on, I'm just going to flip over to my next page. So I'm going to go to page 13. And we are going to do 5 together, but you're going to do 4 on your own. So we're going to do 5, and then after 5 has been done, you should try 4 on your own. So let's take a look at 5. 5 has evaluating the difference quotient. This is actually a very important definition in calculus, one of the most basic definitions in calculus. All right? So later you'll see how this actually pertains to taking limits and things of that nature, but for right now we're just going to evaluate this as is. So remember what I said before, wherever you see an x plus h, or sorry, wherever you see an x, you're going to replace it with an x plus h. So wherever you see that x, it gets replaced with an x plus h. So I'm going to rewrite this entire line here. Okay, so I'm just going to erase this. So wherever I have an x, we're replacing it with an x plus h. So I have f of x plus h is going to equal x plus h quantity squared minus 4 times, again, that x plus h plus 7. So all I did was plug in x plus h for x, and now I'm just going to evaluate this. After my double distribution, we have x squared plus 2xh plus h squared minus 4x minus 4h plus 7. Combining like terms, if there are any to combine, and I don't see any. So we're going to leave that as it is. There's nothing to combine there. Okay, well, what we just took care of right now, guys, so this whole thing right here is this part of the fraction. So I'm just going to write, I have x squared plus this 2xh plus h squared minus 4x minus 4h plus 7, and I'm going to subtract it with, now here is my f of x, and this whole thing is f of x. So it's going to get subtracted, parentheses, x squared minus 4x plus 7, and this is all over just the variable h. Let's do a different color, pink. Okay, this is all over h. All right, so again, I'll just highlight these pieces for you just to clarify. This whole thing is this, and this whole thing is this, which we got from here. Okay, so now I'm just going to simplify. I have, if I distribute here, I'm just going to simplify this. So I have x squared plus 2xh plus h squared minus 4x minus 4h plus 7. Hopefully your handwriting is smaller than mine. I'm running out of space. Minus x squared plus 4x minus 7. That was after this distribution. This whole thing is being divided by h. You guys are going to see things are going to cancel. So I can see here, this cancels, oops, this cancels with this cancels with this, and this cancels with this, which leaves me with the following all over h. So I'm just going to write down here now. I have 2xh plus h squared minus 4h all over h. Because all of these have at least one h in common, this h is going to cancel, this is going to cancel. There's still one left, and this is going to cancel. So I'm left with 2x plus h minus 4. Okay, so again, I know this might seem a little bit complicated, but really you should start to see things that cancel out. So now that we've done 5, I want you to go ahead and give 4 a try. Okay, and again, this is just extra practice. I'm not mandating these other questions, but I do want to take a look now at some function operations. So hopefully remember how composition of functions work. So for a composition of functions, and I'm just going to read off of our definition here. For two functions, f and g, we write this as the composition f of g, meaning that f follows the function g. Okay, so the second function f is then applied to the first function of g. So another way that we can write this could have been f of g of x, such like this. Let me write it out correctly. F of g of x. Okay, that could have also been written like that, as well as this. These both mean the same thing. So as you can see here, this is the same thing as f of g of 3, which if I just plug in, we go from the inside and then we work our way to the outside. So we're first going to look at g of 3 and get an answer. So g of 3, well, let's see. G of 3 is going to equal 3 plus 1, which is 4. Now I'm going to take this value and plug it in to f. So I'm going to now take f of 4, which will be 4 squared, which is 16. Okay, let's just take a look at one more together like this. So we just did A. Let's take a look at C together. So again, we're going to work with the inside first. I personally prefer to write it like this. G of f of 3. So f of 3, we're going to find what f of 3 is first. So f of 3 is equal to 3 squared, which is 9. Now this is going to be the input for g. So I'll have g of 9 is going to equal 9 plus 1, which is 10. Okay, so hopefully we do remember this from previous years. Okay, something to note, this is important. See how I just reversed the order I had, and let me fix that there. I had f of g of 3 and then g of f of 3. Their order was reversed. So this clearly shows that the composition is not a commutative property. Okay, it's not a commutative option, so we can't just start switching things and assume we'll get the same answer. All right, so let's just get some more practice with this. So let's turn to page 15. So we're going to look at question number 2. All right, so we're going to do 2 and 4 together on this page, and you're going to do all of 3 on your own. So for question 2, again, we have the composition of f of g of 4. So we're going to plug in for, well, what is g of 4? And we have, using this function, 7 times 4 minus 1, which is 27. So I now want to take f of 27, since that's what g of 4 was. G of 4 was 27, so now that's the new input value for f. So I'm going to input f of 27 is going to equal 3 times 27. Again, guys, you don't need a calculator. That ends up being 81. Okay, so that's my final answer. All right, so again, using my composition of functions, I want you to do all of question 3, and together we'll do question 4. So for question 4, all right, let's write this out. We want to take g of f of x. All right, and let's see. So we have g of f of x. Well, f of x, we're plugging in x. So if I'm plugging in x here, nothing changes about this. F of x is still just going to be 1 over x. And I'm going to now plug this in. So that is now the input for g. So now I have g of 1 over x, which is going to equal 2 times. I'm replacing x with 1 over x, which leaves me to my final answer as 2 over x. Okay? All right, let's keep moving along. Let's go over to page 16. So we're going to do question 5 together. So let's take a look here. So we have f of x is equal to x plus 1 quantity squared. We want to find the value of f of negative 2 and then f of 5i. We're just going to do f of 5i for our purposes, just because I think you guys can figure out the other one. I want to recall your knowledge on complex numbers. So let's just do f of 5i. So if you want to, for practice, you can do this one, but I'm not making it required. All right. So I have f of 5i is going to equal 5i plus 1 quantity squared. Let's do some double distribute this thing. And we have 5 times 5 is 25. I squared, if anyone remembers what I squared is. We have plus 5i, and then plus 1. So now this is going to be 25 times I squared is negative 1, plus 10i, plus 1. So this is going to be negative 25 plus 10i plus 1, and negative 25 plus 1, I'm just going to write this over here, ran out of space. This is negative 24 plus 10i. So this is an a plus bi form. All right, let's just get a little bit more practice in here, and we'll kind of conclude with these last 4 questions for the day. So I'm going to do 6 with you. You're going to do 7, 8, and I will do 9 with you. Okay? All right, so for question 6, let's write this out. We have x to the 3 over 4, and we want to find f of 16. So hopefully we remember, if I have x to the 3 over 4, remember our power over root. So I'm going to rewrite this actually as f of x equals power over root. So I really have the 4th root of x cubed. And we want to find f of 16, so we're replacing x with 16. Remember, that's your new input. X equaling 16 is our input now. So I have f of 16 is going to equal the 4th root of 16 cubed. And I end up getting 8. All right, and let's do question 9 together, and then you guys can finish up the rest that I highlighted here. So for question 9, I want to know, given that f of x is equal to x squared minus 9, and that's all square rooted, then f of 4 is going to equal what? So I have f of 4 is going to equal the square root of, we have 4 squared minus 9, which is equal to the square root of 16 minus 9, which is equal to the square root of 7. And square root of 7, that is not a perfect square, so this is definitely not rational. So that's out. It's not imaginary. There's no negative under the radical, and it's not undefined. So this actually is a real number. It's just irrational. Okay? Alrighty, let's continue. Now this lesson is a multi-day lesson, so we're just continuing this all together in one video, but I will appropriately tell you guys in our doll when you have to pause and what time frames to pay attention to watch. Anyways, moving on. So now I want to talk about summing functions. So let's take a look. I have f of x is equal to x plus 1. And I have g of x is equal to x squared minus 1. Okay, well, we want to express them in simplest radical form, or sorry, just simplest form. And we're going to sum the functions. We're just going to add them. So f of x we have here, and g of x we have here. So let's write out, we have f of x is x plus 1 plus g of x, which is our x squared minus 1. Okay, now we're just going to combine like terms, if there are any. So this x squared stands alone. We have plus x, and then we have plus 1 and minus 1. And those cancel out, so this is what we are left with. Alrighty, you guys can give letter B a try. I'm going to continue and move on to letter D. You're also going to try C. We're going to do D together. So we have f of x over g of x. Okay, well, I'm just going to write down, we know f of x is x plus 1 all over g of x, which is x squared minus 1. Now, some of you might be like, oh gosh, I do not want to have to do long division. You don't have to. Let's factor. We have x plus 1 all over x plus 1 times x minus 1. The x plus 1's cancel, and I'm just left with 1 over x minus 1. Okay, hopefully that was simple enough. For letter E, we represent this, guys, as a composition of functions. So this is a composition of functions. This reads g of f of x. So we are going to want to find out what is f of x first. Once we get that value for f of x, that becomes the new input for g. All right, so I'm just going to write down, we know, let's do this in blue. We know f of x is x plus 1. And then g of x is x squared minus 1. Okay? So we're going to take f of x. So this is f of x. And it's going to get input into g. So x becomes x plus 1. So our x here becomes now x plus 1. So now I have g of x plus 1 is equal to x plus 1 squared minus 1. We're going to double distribute. Maybe I will show that here. All right, and you guys should be able to figure out the rest, right? Just double distribute. And I see that these ones cancel, and I'm left with just x squared plus 2x. Okay, we are going to do letter F together as well. So for letter F, it says determine what the domain is for the function we found in part D. So here was our original function. We had f of x over g of x, which was x plus 1 all over this x squared minus 1, which we simplified to x plus 1 over x plus 1 times x minus 1. So now before we cancel everything, it says find the domain. Well, let's talk about domain here. For domain, you want to figure out where can x not equal a number. So in this denominator, what do you know x can never be? Well, I know the denominator can never equal 0. So let's set each of these factors equal to 0 and see what can x not be. I'll have x can't equal negative 1, and x can't equal positive 1, right? If I just add over my terms. Okay, well, let's see. Now, if I look at the numerator is unaffected, right? This numerator can be positive, it can be negative, it can be 0. So this numerator is unaffected. It's just the denominator. But now notice, we can cancel the x plus 1s. That doesn't rule out the fact that x still can't equal, it still cannot equal -1. Even if we cancel out these terms, guys, okay, I'm left with 1 over x minus 1. That's because there is a hole, and we're going to explore this when we get to our rational functions unit. There is a hole. This is a little bit more advanced right now because we haven't talked about it yet, but this means there's a hole at x equals -1. If you were to go graph this and check on your table and look in the chart, x cannot equal -1. It will say error. So these are our two values for x in which the function cannot be. So if I were to talk about domain, if I were to write this in interval notation, well, we're going from -infinity to -1, unioned with -1 to 1, unioned with 1 to infinity. Okay, again, all open parentheses because I cannot equal -1 and I cannot equal +1. Alrighty, moving on. Let's turn to the next page. This is now page 18, so let's move over to page 18 now. Okay, now I want to take a look at a different kind of notation. Now, this should be actually new to everybody. So this kind of notation here should be new to everyone. And if you've seen it, great, but I really don't think you would have in Algebra 2. The other notation, sure. Okay, so I'm going to start you guys off, and then you guys are going to get some practice in. So let's take a look at part A. So we have f plus g of 3. If I come up to my notation up here, that's what this mimics. F plus g of x is equal to f of x plus g. So I could technically rewrite this as f of 3 plus g of 3. And we're just going to plug in as we normally would. So we know we're given the following. So let's color code this here. We'll do green and red. So I have f of x is x squared plus 1, but I want to know f of 3. So let's write out f of 3. Well, that's going to be 3 squared plus 1, which is 10. And then I have g of 3, which is going to be 3 minus 4, which equals -1. We combine them, so 10 plus -1 is just 9, and that's my final answer. Okay? I do want you guys to give question letter B a try, since that information comes from here. All right, so give it a try. We're just multiplying the two functions. We will do letter C together. So now, okay, again, I color-coded them above. Now we want to divide f of 4 over g of 4, because again, that comes from our information up here. So this f of x over g of x is equivalent to this statement. So we can just rewrite this as f of 4 all over g of 4. And now we're just going to start to plug in. Well, we know f of x is right here. So I have f of 4 is going to equal 4 squared plus 1, which is 17. And then g of 4 equals, we have 4 minus 4, which equals 0. And they're getting divided, where f of x is, or sorry, f of 4 is being divided by g of 4. So really what I have here is 17 over 0, which is undefined. So my answer here is undefined. All right. You guys can try letter D. I'm going to do letter E with you. All right, so I'll do letter E with you. How's that? Okay. So now again, we just got to follow our notation, guys. This is f plus g of this t minus 4. All this means is f of t minus 4 plus g of t minus 4. So this is now my new input to those functions. And if you remember, we said f of x is equal to x squared plus 1. So this is really just t minus 4 squared plus 1 plus this whole thing, where this is g of t minus 4, where g of x is equal to x minus 4. So we have t minus 4 minus 4. Okay, I'm running out of space, but I'm going to continue working in this area. So I have t minus 4 times t minus 4 plus 1 plus t minus 4, just combining what I have here. When I double distribute, I end up getting t squared minus 4t plus 16. Let's combine some terms here. This ends up being minus 7 plus t. Finally, when we put it all together, we end up with t squared, that's minus 8t, plus t, so that's minus 7t, and then this is plus 9. And that is our final answer for letter E. Okay, I am going to go through letter F with you, and you guys are going to do G. All right, awesome. Hopefully we're doing okay with this so far. I'm just going to erase what's on the screen just so I can make some room. So if you need to, you guys can always go back and rewind. Okay. Okay, so let's look at letter F together. So now this is a composition of functions. So I can really rewrite this as f of g of negative 4. This is typically the form we usually prefer to write this anyway. We know that g of x is x minus 4, so I'll just write that up here. G of x is x minus 4. And we know f of x is equal to x squared plus 1. We are first going to do the innermost part of the function. We have g of negative 4. So let's do the innermost part of the function. So g of negative 4, well, let's see. G of negative 4 will be negative 4 minus 4. We're just plugging in to this function up here, which is negative 8. This now becomes, let's highlight over this in black. This now becomes the input for f. So when I input now my value for f, I have f of negative 8. That becomes the new input for f. And we're applying it to this function, which is negative 8 squared plus 1. Don't forget the parentheses. We have 64 plus 1, which is 65. Okay, hopefully we've been finding this helpful so far. I do want you doing letter G on your own, but I can post what the answer is, sure. The answer that you should get, again, wouldn't it be acceptable to just write this and expect credit if I were to collect notes that day? But that would be your final answer. Okay, let's take a look at page 19. This is just more practice, guys, more practice. All right, so I am going to do letter A with you, and you guys are going to do letter B. All right, we actually have done problems like this already, so I'm going to do A. You're going to try B. Okay, so we have f of x. This is really just f of x over h of x. Same thing over here, h of x over f of x. Okay, I already gave you some help there. Okay, we're going to write, we have x squared minus 4, because that's what f of x is, all over this 2x minus 1. I'm going to use dots because this is factorable. And this is also factorable. I can take out a 2 and write this like this, right? Why not? I can factor out a 2, just now I'm left with a fraction. Now, the numerator is unaffected, right? This numerator can be positive, negative, 0. This has no impact on the domain, none. It's in the numerator. There's nothing wrong with multiplying a negative number by a negative number, positive by a negative, negative by a positive, etc. We don't need to worry about this. We do need to concern ourselves with the denominator. The denominator cannot be what? Well, let's see. Let's set this denominator equal to 0. I'll divide by 2 on both sides. Now I have x minus 1/2 equals 0. So that means x equaling a half will make this undefined. So that tells me in this denominator, x cannot equal 1/2. It can't. So our domain, because if x was a half, right, if this was a half, we have 2 times 0, and that's no good. Now it's undefined. So we would say our domain is all real numbers except for 1/2. Or, so we could write it like this, right, such that x doesn't equal 1/2. Another way we can write this, and again, I'm sorry, I'm running out of so much space here. Another way that we can write this is that our domain, and this is all for this problem, is from negative infinity to a half, unioned with 1/2 to infinity. You're probably going to want to write it this way. Okay, that's probably how Delta Math is also going to pick it up. This is fancy, and Delta Math probably also won't recognize it. So go with this one. Okay? Alrighty, you guys are going to try letter B on your own. I will write what the answer is, just because this is one of the harder problems, because we're dealing with domain. All right, and that would be your answer for letter B. Okay, again, I'm not showing the work because you guys need to do that one on your own. All right. Let's take a look at question 4. Again, I'm going to go through A, and you guys can do B. Okay, so for letter A, we have the following function given to us. So let's just take a look. We have f of 0 plus g of 0. Again, writing it out in the correct function notation now. This is, again, that new notation that you will probably have only learned in this class by this point. I'll just rewrite that, make that a little neater. Okay, well, we want to figure out what is f of 0. Well, f of 0, we want to figure out what's y when x equals 0. What is y, or sorry, what is the output for g of 0 when x equals 0? So let's do this. I'll do f of 0 in pink. So when x is 0 here, for f, we have a value at -1. So this is going to equal -1 plus, now g of 0, well, where is x equal to 0? That's right here. And it just so happens that that also entails this function at this point. So g of 0 is 0. So my final answer is -1. Alrighty, let's keep moving on. Now we have a little bit more practice. I really want to get us really good at function notation. Okay, so again, we're just using that new notation that is new for all of us. So I will do letters A and C with you. You guys have to do B and D. So for the first one, if I take a look, we have f of x and we have g of x. Okay, well, I just want to, in this scenario here we go, we want to add them where the input value is 1. So I'm going to rewrite this as f of 1 plus g of 1. That's what this says. They're the same thing. I'm going to input my values for x equaling 1 and x equaling 1. I have f of 1. This is going to be 1 squared minus 1 plus, we have 5, I'll put it whole thing in parentheses, times 1 squared plus 2. And that information came from these guys, from the functions that were given. Okay, well, you guys don't need a calculator. For this 1 squared minus 1, that's just 0. 5 times 1 squared, this is 5 times 1, which is 5. And 5 plus 2 is 7. So that's it. Okay, we're not using calculators for these. Granted, yes, you have the capability to do that at home, but in general, especially when I taught this last year, almost no calculators are permitted for most of the time. Okay, let's take a look at letter C. So now for letter C, a little different. Now we have multiplication. So we have multiplication. So I have f of 0 times g of 0. Do not confuse this notation with this. They are different. This indicates a composition. This circled, like filled in, means multiply. Okay, so just be careful with that. Don't confuse them. They're different. All right, I have f of 0, so again, we're going to fill in. Now I have, this is equal to 0. So I have 0 squared minus 1, all in parentheses, times g of 0. I have 5 times 0 squared plus 2. We have -1 times 2, which is -2. That's it. I will post the answers for B and D right now. That way you just have them, but again, you need to show work for them. All right, so there are your answers for B and D. Again, you got to show the work. Okay, great. Let's keep going. Again, I just want us getting really good practice with this, so I'm going to do C and A. I want you guys to do B. Alrighty, again, so using that function notation, by this point, we should be recognizing that this can be written as f of 1 plus g of 1. Similarly over here, we should recognize this is g of 3 minus f of 3. Okay, f of 1. So when x is 1, my output is 12. So that was easy. When g of x, when x is 1, my output is negative 4, right? These are my input values, and these are my output values here. Sorry, I just kind of crossed over this. I'll highlight it. How about that? What I have highlighted here in blue, those are your inputs. And in red, those are your outputs. So all these are your outputs. Okay? So g of 1, when x was 1, we ended up getting negative 4. When you just combine like terms, you get 8. Okay? Fix that. All right, when we look at c, I have g of 3. So again, coming over to my table, when x is equal to 3, my y value is 4. So I have 4 minus, again, when f of 3, so when x is 3, my y value is 34. And just simplifying this, this is negative 30. Okay, your answer for this one will be negative 144. But again, you got to show the work. You have to show the work. All right, moving on. And I love this question. Love this question. Requires you guys to get common denominators. Whew. Okay, so I have f of x is x over 2x plus 1. And we have g of x is 1 over x. Alrighty, well, I want to do the addition of these two functions. So this is really f of x plus g of x, right? So I'm going to just add them. I have x over 2x plus 1 plus 1 over x. Ah, shoot. I can't just combine these. You guys need to get the same denominator. So I'm going to multiply by the least common denominator. And in order for these denominators to be the same, this denominator is missing an x because this one has an x. So we need to multiply top and bottom by x. And then this denominator is missing a 2x plus 1. So we need to multiply top and bottom by 2x plus 1. Okay, and now we're just going to start to simplify. Guys, the denominators don't just cancel. Like, you can't just get rid of them. So we'll end up with x squared, because we multiply these together, all over. I'm not going to distribute this yet. I'm going to hold off. Plus, because they have the same denominator now, and this is just a 1, so this is 1 times 2x and 1 times 1, so plus 2x plus 1. Now, if I really want to, and we probably should, let's distribute the denominator. You could factor the top. You'll have x plus 1 and x plus 1, but that doesn't help us cancel anything, so I'm just going to leave it. So I have x squared plus 2x plus 1 all over 2x squared plus x. Okay, just a common mistake I want to address. You can't just start canceling x's because you feel like it. Can't do that. This one doesn't have an x, so you can't start canceling things. All right, so in the end, you have x squared plus 2x plus 1 all over 2x squared plus x. Okay, great. Why don't you guys try 4? So we just did 3. You guys are going to do 4. And I'll just write out the final answer for when you do get to it. But again, you need to show the work. Just leaving my final answer and turning in that work will not receive credit. Not receive coursework credit. I need you guys doing the questions I'm asking you to try. And if you have questions, please contact me. Ask me for extra help. Email me. Okay? All right, let's keep going. We're almost done with this lesson. I know this was a long lesson, a lot of information because there's a lot of new things going on here. Okay, let's look at question 5 together. So for question 5, I'm only just going to do one of these, and you guys can do one of these as well. We don't need to go crazy with it since I've given you guys so much practice. So I'll have you guys just do C. All right, so we have, and again, we're going to write this out. This is really just g of 0 all over f of 0, which equals, so g of 0, so here's my graph for g. So here's where x is 0, but my y value is down here at negative 5. So g of 0 is negative 5 all over, we want f of 0. So here where x is 0, but I want to go all the way up here, and f of 0 is 5. When I have 5 over negative 5, I get negative 1. Again, just to give you guys the answer here for C, your answer is negative 7, but I need to see the work. Okay, we're almost done. Ooh, love question 6. What a great question. Let's do it together. So for question 6, we have natural log. We have m minus p of 1, which is m of 1 minus p of 1. So again, we're just going to evaluate. M of 1 is just the absolute value of 4 minus 1 minus the natural log of, I should put this all in parentheses, natural log of 1 minus 2. Okay, keep going. Let's just start to simplify. Absolute value of 4 minus 1 is the absolute value of 3, which is just 3, minus, I'm just going to distribute, the natural log of 1 plus 2. Again, combining like terms, 3 plus 2 is 5, so I have 5 minus the natural log of 1. If you guys remember, the base for natural log has a base of e. This is really saying 5 minus the natural log base e of 1. So this is saying, if I were to rethink this, e to the what gets me to 1. This is, again, what this is saying. We're going to hit a unit all on log, so don't freak out if you're like, oh my gosh, I don't remember this. Okay? E to the what is 1? Well, when this is 0. Anything to the 0 is 1. So this is just saying 5 minus 0, which is 5. So my answer here is just 5. Awesome. Okay, and again, I'm going to let you guys try. I want you guys to do questions 7 and 8. I'll just post the answers really quick. Your answer for 7 should result in 408. And your answer for 8 should be a squared minus 9. That should be your final answer. All right, guys, we are done with this lesson. I will see you tomorrow.